You're saying 8? Nope, that's review 1.
Also, don't feel bad when the 2K one. I just want to get away from that.
Yeah, right. Alright, so here we go. Guys, start off with 8. That's what you're saying, right? 8. Alright, so, yes, sir. No, you don't get one. Ladies and gentlemen, come on, let's go. So, first thing you gotta do is move to 7. Now remember, these numbers and stuff, you don't have calculators, so you should be able to do these things without too much of a hassle. Divide by the -5 gives us positive value, 27. So now you have equals x over 5, 3/2. How do you undo the exponent of 3/2? You're halfway there. You were right with the cube root squared power, so you just, how about we just say 2/3? That's all right. All right, what's the cube root of 27? Square it. There you go. What's that? It's 8. We probably did. I don't know. Which one? Sure. First thing you do is multiply both sides by -1/3. Instead of saying divide by -3, multiply by the -1/3 and watch what happens with your. When you multiply both sides by the 1/3, look what happens on the other side. 3's go.
Did you get them out?
You wind up with 1/4 equals to that. Okay. How do I undo the -1/2 power? -2. Very good. That fraction is no longer happy. Flip it and square it. So you get 16. Then from here it's really fast. Excuse me. 2x is 16. You get 8. Isn't multiplied by 1/3 the same as divided by 3?
Yeah.
That's why.
Did you
No, I'm just, because I had to undo the multiply by -3 first, so I multiplied both sides by -1/3. And then I took care of it. Still there. Here we go. Usually you're not going to get extraneous with this style. It's the other ones where you have to square stuff because you can wind up getting answers that are answers. That's usually where you have to worry about it more on. Not like a moron, but more on. Speaking of morons, what's up? Michael?
Oh, hi.
Sorry. Sure. All right. So in this case here, right off the bat, you gotta square both sides. Okay. So when you square both sides, you wind up with -1 minus 2x x squared. I just changed the x's. Okay. Set aside equal to 0. X squared plus 2x plus 1. What times what is 1? You add together, get 2.
B plus 1.
1 and 1. Hey, look at that. 1 has multiplicity. Or -1 has multiplicity, sorry. So this is the one where you're you're not going to get it's an extraneous solution, because remember when you substitute those back in, your square roots aren't going to become negative, okay? Because you're not taking the square root of both sides. That's when you do plus minus, when you're rooting both sides. In this case, you're going definitive off of that. You're not going to get a negative root. Okay? So this one would have been no solution. I think if you saw the answer guide, sometimes they put it as what's called an empty set.
21 is
For which one did you say? 21? No solution. My answer guide says. What else we got? Yeah, so here's the trick. When you've got two roots on the same side, make split, put one on both sides. That's the trick, okay? Whenever you have two roots on the same, because if you squared it now, you'd still have the double root in the middle. So you'd have a root times a root, which just gets really... So move that 5x plus 1 to the other side, so it'll be plus the root 5x plus 1, and then square both sides. That's the trick for this style problem. That's the trick. So now when you square both sides, it works out pretty quick. So we have 10 minus 2x, 4, 5x plus 1. And remember the trick. Multiply the two together, double it. So you get negative 4 root 5x plus 1. Okay? Combine your like terms, we get 5x plus 5. I'm going to get 5x plus 2x minus 10. And I just brought that back over to the other side. So is that 7x and a negative 5? Divide them both by 4. And I got that. Hi. Oh, I had it erased here. Remember the pattern. When you square something, square the first, square the last, multiply the two together and double it. It's the shortcut. Or just FOIL it out and you get the same thing. Well, this is fun now. Squaring. Okay? So 5x plus 1, 49x squared, 16. 25, 16. What's 7 times negative 5? So you get negative 35 over 16, but then I double it, so it becomes over 8. Get rid of the fraction. Yes, sir. You could do that, because then you just get 16 times the quantity, which basically we wind up doing right now, because you're going to get the same result. So that's 75. Not 75, 70, sorry. Okay. Oh, I forgot to square the 9, or the x squared here. Well, that looks like a lot of fun. Was this 80? So subtract 80. Yeah, that looks great.
Yeah, I hate it.
Yes. There was one right near that one. I think we actually did in our notes where we had the 1/2, 1/4. There was another one fraction like that that worked out really clean. You're just looking at me like you want to kill me. That's true, and I'm used to it. This one's, guys, at this point you can use quadratic formula. It's just gross, but whatever. What's up?
Why did you divide out the 4 with all the fractions? Because you can just square the 4.
You get the same thing because you still have to square all that out and multiply the two together and double it. You wind up the same spot. I'm just showing that you go both ways. It works either way. Okay. Most people, when they square that side, you forget to square that 4. That's why I just bring it back. What else we got? Freeland. You just want answers. You don't want to know how it works. Typical. Whatever. Whatever. Yes.
Wait, are these posted on the Friday?
Should be all there. Alright, so in this case here, square it where it is because you don't have to worry about moving anything. So when you square it, first term squared, jump squared, so it's negative 9 minus 2x. Then I have to multiply these two together and double it. Oops. So I get plus 2 root negative 9 minus 2x. Okay. Yep. Start moving stuff around. The 2x's drop. This becomes negative 8, so I get this equal to 2. Well, that's convenient. Divide out by the 2. Square it. Add and divide.
How'd you get 2 on the right?
Negative 9 and 1. Negative 8. Add it over. It's mathemagical.
It's a Monday.
On a Tuesday.
It's Tuesday.
Merry Christmas!
That's Coleman's line.
You're one day closer to the weekend.
And we're one day closer to Christmas.
One day closer to death, but who's counting?
Yeah, exactly.
What else we got?
Could we do, no.
Grade 11 personal learning. All right, 11. So right off the bat, guys, I have to undo the exponent. So undoing the negative 4/3 means I'm going to use negative 3/4. So you get x equals, and this is negative 3/4.
Did we ever use negative exponents to cancel out other negative exponents?
We just did.
Well, I mean, we just did.
Well, we whenever we were solving the equations, we never really did that because all of our exponents are generally positive. But then as we got into this stuff, we realized we could have negative exponents, and you're just using reciprocals, and you get 1. So that's where it works itself through. Remember, when you have a fraction that's negative, just flip it. Flip it, the exponent becomes positive. Now that means it's the 4th root. Remember, 4th root means you're just taking the square root twice. What's the square root of 256?
16.
What's the square root of that?
4.
What's 4 cubed?
Yes, it is 64.
So you get that.
Wait, what is it?
One to the 4th rooting is your square rooting twice.
Yeah, but there's no like words.
4th root? No. It's just called the 4th root. Okay. You were saying number 9?
Yeah.
Number 9, then I gotta give you a sheet here to look at some other stuff.
What about the power of infinity? Power of negative.
Add 2, divide by -2, so you're gonna get the right side equal to 2. So you have -4 divided by -2 is 2. How do you undo 5th power? 1/5 power. What's 2 to the 5th?
32.
To the math, yeah. Equations, yay! So if you're doing math, that means you're probably geometry right now? 353? Or are you? Okay. Abstract is awful. Seb and I, Paul Severino, I think he does more of the 301 classes for you guys. He and I were graduated through Northern, and we were that group 15 years ago that made it change. So if you heard rumors about it, yes, that was us. Yes. Well, let's just say that there were certain things that were going on in that class that shouldn't have been going on, and we had to change things. Let's just say I'm a little thick-headed.
They should
That's terrible. No, I didn't. For once. All right, let me give you the other sheet that I have here. So the other thing I made up for you guys was some of the reviews on how it works. Nope. I did. They made our life.
I don't know.
Alright, so the other thing I wanted to go through with you guys. Gentlemen, come on. Last little bit to go through on these is obviously I'm going to go back and if you have other questions that I didn't get to off the equation stuff, just throw my desk. You can give it to them if that's what they want. We'll go through those. But what I wanted to do is kind of revisit a few of the what we did at the beginning. And bless you. One of the things that we first looked at was this function notation. And what I wanted to remind you guys of excuse me, is how it works. Whether it's dealing with numbers or dealing with f of g of x and things like that, the shortcut ways of making sure you set these things up correctly. Now remember, oops, that didn't snip. We are still testing tomorrow. This one, I have the answer key is up here. If you want to take a picture of it, please do so. Otherwise, the PDF will have the answers on it as well. I should also be able to do a worked out key on that and throw that on there as well. So this one's actually pretty quick. The function notation, remember, start at the innermost parentheses, and then that starts playing the role of x as it goes outward. So I'm taking -2 into the h equation. So you get 4 times the -2, add the 3. you get -5. Okay. From there, you take that into the g equation. -5 cubed plus 4 times -5. When it's numerical, I would solve them first, and then I'm going to show you. This one didn't have it didn't generate like an f of g of x type of situation, but I'll make one out of this one here in a second to show you what I know what you're asking. What's -5 cubed? And then what's -125 and -20? Okay. Now, in this same scenario, what if it was, excuse me, h of g of, well, these are usually n's. I'm just going to say x because it might. The trick for this was write down the g equation, and then that's starting to play the role of the x in the h equation. Okay. So whenever you have composite functions like this, innermost tells me to use that. So x cubed plus 4x, that's now playing the role of the x here. So you surround it now with the h equation. And the only thing you can do here is distribute. And you're done. That's it. There's no solve for 0, there's no nothing else. Composite function. Okay. It's just a straight composite function.
But that's just the inverse.
Not an inverse.
Or not an inverse, only because the -2, right?
No, that's just substitution. Okay. Inverses are some totally different options.
So if it's just x, then you just input x.
Yeah. So I was throwing that, make sure I showed you how to do composites again. Okay. They're not tough. Just remember, always start with what's in the middle and surround it. I probably won't make you cube it, because that's just mean. I mean, me, but not that bad.
You're bad, but you're not that bad.
Yeah, there's certain levels. Okay.
Standards.
Inverses. There was a lot of questions when we got into inverses, especially for number 5. People forgot how to do this. So when you're dealing with inverses, what was the rule? Remember? Yep, flip x and y and resolve. Now, the reason why I wanted to show you one like number 5, so that means I get x equals 1 over y minus 2. What do you do first? Okay. Why would you? Let me ask you this. Does that change anything? Now, remember, when you have fraction equal fraction, that means they're ratios that are proportional, right? Ratios that are equal are proportions. Now, when you did this, true or false? True. Okay. What happens when you flip them on the diagonal? Still true, right? So what happens whenever you get ratios that are equal to each other, you can exchange things along the diagonals, and it's still a true statement. You're saying cross multiply, but this means I can just flip-flop these two. Y equals 1 over x plus 2. And you're done. Yes, sir? Technically, yes. As long as you group the x plus 2, you're all right. Okay. Just a reminder, when you have fraction equal fraction, you can do that. The diagonal stuff works. You guys did this a lot. I think first hour was saying you guys called it the Italian switch or something like that.
Oh God. You Italian.
Was that what you guys called it? The Italian switcheroo?
Yeah, that was very hard.
Yeah, because I was just calling it, I used to say exchange-o, change-o. That's me. Exchange-o, change-o. All right.
That's why I asked you this.
Verifying. In order to verify, Not really. Well, I see what you're saying. Shh, guys, there's a lot of this stuff to get through. Basically, you're putting in one for each other, and you're resolving it and trying to see if you get x. Okay. So I'm just going to rewrite these in terms of x. That's what I'm used to just writing that, but it works the same. So remember, this means you're going to first write down the g equation, 2 over x minus 1, and now that's playing the role of x in the f equation. Fraction divided by fraction, isn't that? Isn't that the same thing as saying 2 divided by the quantity 2 over x minus 1? Yeah. So you multiply by its
reciprocal. What is it? Is it reciprocal?
Order of operations tells you to multiply first, doesn't it? What happens to the 2's? No. What's negative 1 and 1? Works going one way. Now you go back the other way. Start with the f equation. Okay. So this right here is a giant fraction. Okay? Which means it's the same thing as saying 2 divided by 2 over x minus 1, and then it's plus 1, because plus 1 is tacked off to the side. It wasn't part of the fraction. Then you can flip it and go. Does that make more sense when you write it that way?
And so if x equals x, then it is.
Yes. Well, they both have to simplify to equal x. If they both simplify to equal x, then they're inverse. I'm doing that right now. Okay. So again, back to this here. Oops. Order of operations, the 2's drop, you wind up with x minus 1 plus 1. Sir? I can't hear you. What do you mean? I did, I just multiplied by addition. Because that's what it started with. Good morning. Now I'm starting the other way. Start with the f equation, surround it with the g equation. Sir?
Isn't there another way to find out if two equations are inverse just by ignoring one of the equations?
You have to officially show it works, you have to go both ways.
Okay.
Okay.
Well, I mean, if you get the other equation.
What do you mean?
Well, so if you inverted one equation, you got the other equation, isn't that true?
That's not how you verify them. To verify them, you put them in for one another. F of g of x equals x, and g of f of x equals x. That's how it's verified. Okay. Yep. Again, order of operations, these guys drop. You wind up with 2 divided by 2 over x. Flip it, and you get x over 2. You get the same thing. That's how verification works. Okay. All right. Excuse me. Exponents. Remember your rules of exponents. No, excuse me. We should have positive exponents, no negatives as you go through. Power to power, what do? Multiply. So you have negative m, n squared, m to the 20. Is the m negative or does the m have a negative exponent?
M is negative.
M is negative, so does it move anywhere? No. Nope. So what's its exponent? 1. 1. What's 1 plus 20? So your answer is negative 1, n squared, m 21. They put those negatives in front of the variables like that, just the straight negative, not a number, to mess with you, to make sure to try to catch you without moving it. Okay? That's how they set those things up. It is. Same idea here. You've got your power to power. What do you do with power to power again? Multiply. So you get negative 15, negative 25, so m, negative 25, n, negative 15. Again, it's a negative 1m and an n to the negative 4. Make everything positive, which means a lot of stuff's moving. So you have negative 1. And what happens with the m's? What's that? It's simplified. So you just have negative 1 in the numerator, and this becomes 24. Okay. Play war. Excuse me. Fraction ones, again, remember, simplified all the way through. No fractions in the denominator. I think when I was making the sheet, I wound up picking the other ones first before I got to these. That's why they're at the end. No big deal. What's anything to the 0 power? 1. So what happens to that first chunk with y to the 0 to the 5/4? It just all becomes 1, so I just don't even bother with it. Okay. From here, you've got a couple of things to choose from. You have an x and an x to the 3/4. Play war. Yep. X to the 1/4 up top. Okay. Since these guys, that's just a 1 and that's a fractional amount, if you rationalized it, you'd have to multiply top and bottom by a 4th, then you'd have a whole and a whole plus some. You'd still have to simplify out. Okay. So always look to see if you can simplify before you have to do any rationalizing. This goes away, you end up with just x to the 4th in the numerator. Okay. So when you do that, you're right. You got 7/4 up top, 2 on the bottom, which means, excuse me, it winds up being how much in the denominator?
Y to the 4th.
1/4. Good. So you have y to the 4th. Now, I can't leave it there. How many more fourths do I need in this case to make the whole? 3. So you go top and bottom with 3/4. There's a couple of ways of doing that, yeah. So you wind up with x to the 4th, y to the 3/4 over y. Okay. Whenever you have fractional exponents and whole value exponents, you got to make sure that your fractional amount is less than 1 in the numerator. Because if it's greater than 1 and you've got a whole in the denominator, it can still simplify. Well, yeah, because 4/4 is 3/4. Who wins? 4/4, so it just subtracts up. So it's like x to the 5th over x squared becomes x to the 3rd. Let's look at 25. Once again, when you start thinking about order of operations and stuff, when I'm looking at one at 25, well, no, you want to cube it. That's not what you would do here. You're not solving for anything. Simplify the interior first. What's squared times 1?
A third.
All right, so I wind up with a cubed. Now, b squared, b to the half, who wins?
B squared.
What's 3/2? Good, so that becomes b to the 3/2. Now I have my exponent of a third. Power to power, what do you do? Multiply. By taking care of that stuff first inside the parentheses, you have less work to do now. Plus, you don't have to worry about any fractions then. It's a lot easier. Okay? So you get a, b to the half. That's your answer. Okay. Work inside out. It's cleaner. I did. I played Warrior.
And you got
$2 minus 50 cents is $1.50. Yeah, we're happy to do that one. Excuse me. Yeah, there's really not much screwy with those. I know that you guys always freak out when you see fractions.
Always.
But I think we actually did this one in our notes last week, if I'm not mistaken. Do you guys all agree in this case here, you got to move that -6? How do you move it? Add it. But I'm going to add it in terms of 30 seconds. So multiply it by 32. So yeah, that's where this, I'm pretty sure we did this one in our notes last week, guys. So you wind up with 192 over 32 minus 191 over 32 is, okay. What's 192 minus 191?
131.
How do I undo that exponent now? -6/5. Make that fraction happy. It's nice when it's just 1 over, you don't have to worry about it. So you get 32 to the 6/5. And then that was what, x minus 8? Okay. What is the 5th root of 32? 2. What's 2 to the 6th then? There you go.
Yeah.
I just didn't rewrite it. It's the same thing. I keep moving down.
It would just be X.
Yep. Sometimes when I get going on a lot of this stuff, I'll just write the parentheses because it's the same thing that's in there that I'm using, so it hasn't moved or anything. I know I kind of moved through a lot of this really quick, but what is the style of one you wanted to see? Because I think we've got until what? 17? Oh wait, 46. Oh, we got about 7-8 minutes.
That's a good amount of time.
Screw you, Freeland. I was trying to be, you know. Do me a favor. Will you take the knife out of my back? Your sister was much nicer than me. I'm glad you're here. All right, so here's a good question. Here's a good question. When you're looking at, guys, when you're looking at big numbers, the 5th root of 1024. Now, here's what you, I mean, obviously, you know that this goes to the 3/5, okay? Now, we know it's not going to be 2, because 2 to the 5th is 32. 3, well, what's 3 to the 4th? You guys remember how to do that? Remember, that's 3 squared squared. Okay. So if I go to 4 to the 4th, that's 4 squared squared. Okay. So 3 squared is what? Square that, you get 81. So that's 81. If I do another 3 here, what's it going to end in? Get into 3, isn't it? Okay. What's 4 squared? Square it. If I multiply that by 4,
That's the
that's, I guess. So 4, think of it in smaller chunks and work your way up. Right? Don't try to do it right off the bat. Oh, what's the 5 will jump? Break it into smaller pieces. Because the 5th power is 4th power and 1 power. Okay? break it into smaller pieces. Okay. So this would be 4 cubed. And what's 4 cubed?
64.
64. And then you go from there. The numbers might look ugly, but they're all workable. Sir?
Can you go through the multiplying thing where you find out what bit ends in?
Well, we know that this is going to be, if I multiply this by a 4, what's 4 times 6? So it's got to end in a 4, doesn't it? What's 3 times 1? 3, so it's got to end in a 1. I'm sorry, end in a 3. Hello. It's just a little shortcut trick, okay? Or just multiply it out. Or how about this? 4 250s is 1,000, isn't it? And that's pretty darn close to 1,000, isn't it? Yes, ma'am.
Okay, so this one's like really it's just it would just be y
Was it y 0? And then x to the negative. Power multiply. So you just use that now. What other side you want to look at? Same idea here, guys. Oops, that didn't go. This stinks. Square it right away. So when you go to square this one, you're going to get 16, 7 minus x. Negative 4 times the negative root gives us 4. Double it gives us 8. Okay, that's my left-hand side. Other side is easy, it's 2x plus 2.
So what after that equation when you square it? Oh, I think you can only help this. Yeah. So you have to do a squared plus 2. Yeah. We don't. You gotta square everything.
Okay. So you start moving it around. Add this, we get a 3x. What's that? 23. So it'll be minus 21. All right? Yes. This is gross.
Yeah.
For some odd reason, I sense some sarcasm there. Just a little bit.
Wait. It's negative 16 plus negative 7 is negative 23. Isn't it? Or wait. You're getting
16 and 7 is 23.
Oh,
Subtract it over and get negative 21.
I thought you were saying minus 21 and not
Oh, gotcha.
negative 21.
Now here's, oops. Now in this one, let's try the other method. Square it where it sits now instead of dealing with the fraction. If I square it where it sits to start with instead of dealing with this fraction, I have to square both of those. What's 8 squared? 64. So now if I do it this way, I get 64 times the quantity 7 minus x. Then over here, we get what? 9x squared. 21 squared is what? 4. Oh, geez. It ends in a 1. 421? Help me, you have a... Ah, you're right. 441. I was close. And then move these two together. That's 63. Double it. Yeah, I'm doing that. So 63 double it is what? 126. 64 and 7. That's gross. 8, 2, Was it 42, 44? So 448 minus 64x. You're right. Hey, which means, won't they be a little bit cleaner than something like that? I would imagine so. I should, shouldn't I? You're right. What times what's negative 63? You add together to get 62. It's factorable, so. PDF will have the answers on it. I think it's already on the calendar. If you got questions, swing by in the morning. See you guys then.
That depends on how much work I have. I'm almost like I didn't take so
Yeah, I mean, I like totally like had a brain fart during my course.
Mind fart, brain fart, they're all the same.
It was the worst thing in the world. I was like, oh. Yeah. You know that's
No, not today, 'cause you had that survey. Good times. What do you got? I rarely, I haven't had an AC. I've only had an AC chart maybe once in the past 5 or 6 years. I just didn't feel like
I just noticed all the guys were on the side except one, and then all the girls were on the side except one. So I was like, "Is that purposeful? They choose
They just kind of did it. And it was just this class that did that. The other classes are all mixed up. But yeah, this group was really weird. They just were all
girls on the side, all guys on that side. I was just wondering.
It was weird. They talk a lot together. It's how they are. It's fun.
And juniors?
Sophomores, mainly sophomores, some freshmen. There's a couple of juniors here, but it's the honors out there too. So yeah, we have mainly sophomores. I'd say.
Okay.
Did you already finish your grade?
Yeah, she knows her level started.
Oh,
So, I was doing stuff.
that's fine. No biggie. See you guys. We'll see you next week.
Yes.